Okay, to follow up on the first video, the two problems that we did, and these are the equations of them, I've graphed them. This is the first problem we did that had the two solutions, the two real solutions. This one in red had the two imaginary complex solutions. So as you can see with the graph, I'm going to see if I can move this. Let me move it. Yeah. Excellent. I'll move it over here. You've got two, you cross the x-axis in two spots here for this. And with the one with the imaginary, the complex solution, when we use the quadratic formula, you'll notice it doesn't cross the x-axis at all. So it has a solution, okay, for when y is 0, but it's a complex solution. It is not in a set of real numbers, so it does not cross the x-axis. So that is what that means. So you can actually tell really, really quickly without doing the entire quadratic formula. You can find out pretty quickly whether a quadratic is going to have two x-intercepts or two zeros, no x-intercepts, or one x-intercept. Now for it to have one x-intercept, it would be a parabola that is sitting on the x-axis, where the vertex sits on the x-axis, so it only touches the x-axis in one point. To break it down, this is how you do it. You take the stuff that's under the square root. This stuff right here, this is what's under the square root, b squared minus 4ac. It's called the discriminant. Okay, if you just look at the stuff that's under the square root, you can tell how many intercepts that parabola is going to have, that quadratic is going to have. If your discriminant is less than 0, meaning the stuff under the square root is negative, which means you're going to have a complex number. You have no x-intercepts, no zeros. Okay? If d equals 0, that's when your parabola is sitting right on the x-axis. It's only touching the x-axis in one spot. It has one x-intercept. Your discriminant will be 0 in that case. If your discriminant is greater than 0, then you will have two x-intercepts. It will have two zeros. It will cross the x-axis in two spots. And that's really all there is to it. You can check very quickly by plugging your numbers in just into the stuff underneath the radical for the quadratic formula called the discriminant, and you can figure out a little bit about what your graph looks like, whether it's going to cross the x-axis at all.